Hello everybody, welcome to Advanced E-Learning Chemistry videos. Today I'll be showing you a game related to significant figures. After this game, it will be very easy for you to understand the rules related to significant figures and analyze which digit at which position is significant. First of all, I would like to give you the review of the whole game. Here you can see two boxes. One is a whole number box. That means the number without any decimal point. This one is a decimal number box and this is the decimal point. On the top, I have taken different digits like 1, 2, 3, 4, 5, 6, 7, 8, 9 and zeros. We will be using these digits at different locations inside the whole number box and the decimal number box. On the right hand side, you can see all the rules here, and you can see the button associated with every rule. So when I will be pressing this button, the particular rule will get applied, and then these digits will start entering these boxes as per this rule. And in case if any of the digits, say like 0, is not able to enter this box, or it enters the box and bounces back to the original position, that means as per this rule which I've applied, that digit is not significant. Here I have taken 0, so like 0 is not significant. So that depends upon the rule that I have applied. So the basic rule is if any of the digits enter these boxes and stays, that means they are significant at that position. If any of the digit is not able to enter the box, or they enter the box or bounce back, that means they are not significant for that particular rule. So now you have got the review of the game. Let's start. First of all, the rule 1. Here you can see that I've applied this rule and this button has changed into green. Now whatever will happen, it will be as per the rule 1. So let's see. You can see the non-zero digits are entering both the boxes and they're staying inside those boxes. As you can see here that these numbers have entered the box, which is a whole number box, and they are staying in this box. That means these digits are significant. One thing I would like to tell you, when I'm talking about these digits, other than 0, I will be taking other numbers randomly. So like if here I have not taken 3, that doesn't mean that 3 is not significant. These numbers represent as a collection of this non-zero digits. So I will be just taking randomly any of the numbers. So if I'm taking just 1 to 5 of them, that doesn't mean the others are not significant. They are also significant in that sum. So here I am taking the collection of non-zero digits as one whole concept. Now here again you can see that these non-zero digits, whether on the right hand side of the decimal point, whether on the left hand side of the decimal point, are staying in this box, in this decimal number box. So what does this mean? Let's see. So that means these numbers, that means all these non-zero digits are significant. Now let's see what happens to 0. Oops, this 0 is not able to enter this decimal number box. Let's see whether it is able to enter the whole number box. No! You can see here that the 0 has bounced back. You can see here that the 0 has neither entered the decimal number box, neither it has entered the whole numbers box. So what does this implies? It shows that all non-zero digits are significant figures. That means as per the rule 1, 0 is not considered as significant. Only the digits which are not 0, that means here from 1 to 9, are significant. Again, I would like to tell you that I'm taking the collection of non-zero numbers as a one whole concept. So I'm just taking and picking up randomly any of the non-zero numbers. here I have pressed the rule 2 and this button has changed into green. Now that means the digits will enter the box or they will not enter the box as per the rule 2. Here you can see all non-zero digits are significant in case of whole number also, as well as decimal number. Oh, this 0 has moved into the decimal number box and it is staying there. Same goes for the 0 in the whole number box. So if you analyze here, in case of whole number box, that 0 is placed between two non-zero digits. And same goes for the decimal number box, that the 0 is placed between two non-zero digits. So what does this proves? So this rule states that all zeros occurring between non-zero digits are significant. So that means if the 0 is placed between two non-zero digits, whether in a whole number or in a decimal number, it is considered as significant. So this was rule 2. Let's see the rule 3 now. I have pressed the rule 3 and the button has changed into green. Now the digits will enter as per the rule 3. Here you can see that this decimal number box has been closed. That means that this rule 3 is applicable only for whole numbers. Let's study this rule. You can see here that the non-zero digits are entering the whole number box. Now let's see what happens to 0, whether the 0 will get placed or not. Oh, it's bouncing back. It has entered the whole number box, but it is bouncing back and it has moved to the original position, and we have a cross here. You have just seen that the 0 entered this whole number box and it was not able to stay inside this whole number box as per the rule 3, and it bounced back and returned to its original position. So what I'm trying to say here is that 0 on the extreme right of a non-zero digit in a whole number is not significant. That means in this case the number of significant figures will be just 3. So this 0 is not considered as significant. Like if I take 2, 1, 0, 0. So in this case only 2 and 1 are considered as significant, and these zeros on the extreme right of a non-zero digit in a whole number is not significant as per the rule 3. So all zeros to the right of a last non-zero digit are not significant. The number should not be a decimal number. So that's why this decimal number box got closed. So this was rule 3. Let's see the next rule. Rule number 4. As you can see that this decimal box is open again. So that means this rule 4 is applicable to both the whole number as well as the decimal number. Let's see what rule 4 has to say. For rule 4, 5 and 6, I will be just writing any random numbers inside the whole number box as well as the decimal number box, because we know that as per the rule 1, all non-zero digits are significant, whether they are at the extreme right or at the extreme left, they are on the left hand side of the decimal point or the right hand side, it doesn't matter. All non-zero digits are significant. So I won't be showing them entering the box. I will just place them. I have just placed any of the random numbers. We're just concerned about the placement of the 0 in these rules. So let's see what rule 4 has to offer. You can see here that the 0 is entering the decimal number box. It is not able to stay. It's bounced back. It's bouncing back, and it has moved to its original position. And here again, it has entered the decimal number box, and again it has bounced back. You just saw that the 0 entered this decimal number box to the right of the decimal point, and it was not able to stay and it bounced back. Again it entered on the left on the decimal point, and again it was not able to stay and it bounced back. If you analyze these three positions, then they are the starting of any non-zero digits. So that means these positions are considered as the starting positions, or what we call the leading position, and the zero at this position will be considered as leading zeros. So that means when the zero is placed as leading zeros, they are not considered as significant, because this zero bounced back from this position and from this position. So as the zeros here are considered as leading zeros, so what we're gonna say is that leading zeros in case of decimal number are not considered as significant. Now let's see what happens in case of whole number, whether the zero is able to enter this box or is able to stay inside this box or not. Now the zero is entering this whole number box. Let's see. Oh, it's bouncing back. So if bouncing back, and yes, it has moved back to the original position. So we have a cross here. So that means in case of whole number also, this leading zero is not considered as significant. So what does this prove? This tells that as per the rule 4, all zeros to the right of a decimal point and to the left of a non-zero digit are not significant. That means we are talking about leading zeros here, that they are not considered as significant, whether we take a whole number or we take a decimal number. So this was rule 4. Let's see what rule 5 has to say. Here I have entered the rule 5. And you can see here that the whole number box got closed. So that means this rule 5 is applicable only for the decimal number. It is not applicable for the whole number box. Again, I have placed any two random non-zero digits inside the box, and the zero is entering this box, and let's see, oh, it's staying at this position. Again, another zero came and it's staying at this position. So we just saw that the zero entered at this position and it's staying there inside this box. That means zero at this position is considered as significant. Again, the zero at this position is also considered as significant in a decimal number box. So what this rule says, it says that all zeros to the right of a non-zero digit. Here we have a non-zero digit, and the zeros to the right of this non-zero digit, if a decimal point is specified, are significant figures. That means these zeros are considered as trailing zeros because they have some non-zero digit in front of them. So these zeros are trailing zeros, and they are considered significant as per the rule 5. In case decimal point is specified, that means in case of decimal number. So this was rule 5. Let's see the last rule, which is rule 6. Now let's see what rule 6 has to offer. Here you can see one number coming here. It's not entering any of the boxes. Okay, then 0 is coming, it is not entering any of the boxes. Then 7 is placed as a par. So that means this rule is related to par. Now we should check that whether the par in case of the decimal number as well as the whole number is considered as significant or not. Let's check. Here you can see that this 10 with the raised to power 7 is entering this box. It's bouncing back and it has moved to the original position. So that means the par or what we call at exponent is not considered as significant in case of decimal numbers. So let's see what happens in case of whole numbers. As you can see that this par is entering the box, it's bouncing back, and yes, it has moved to their original position. So that means par here in case of whole number also is not considered as significant. So as per the rule 6, par in case of decimal number and in case of whole number is not considered as significant. So the rule 6 implies that the pars are not considered as significant figures. So now the game finishes here because we have covered all the 6 rules related to significant figures. I'm sure that after watching this game, you would be able to solve the questions related to significant figures. Now you know that at which position 0 is considered as significant and in which position it is not considered as significant in case of whole number or in case of decimal number. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.